This is a jaw of a duck-billed platypus, Ornithorhynchus anatinus. And there are a couple things about this jaw that I thought I'd show you. First of all, is the fact that it doesn't have teeth like you and I. Rather, it has this keratinized pseudo tooth. And you can tell in part because the tooth itself doesn't have roots in the traditional sense. On this particular specimen, the right tooth happens to have fallen out, so you can see a bunch of nutrient foramina, but there aren't any tooth roots. And that is correlated with the fact that the tooth itself is not enamel and dentin. It's a much less dense structure. It's made of keratin, so we can change the transfer function so that the CT scan does not render dense objects, at least objects that are less dense than bone. And you can see the bone still is there, but the keratin is not, reflecting the fact that keratin is less dense than bone and certainly much less dense than enamel and dentin. So let's bring that the keratinized tooth back. Another interesting feature of the platypus jaw is the size of the mandibular canal. That's what carries the third division of trigeminal that innervates the lower jaw. I have a clipping plane here that will enable you to see that. And there it is. That it enters the lower jaw from the back, from that aspect, for example, and it pretty much takes up almost the entire internal aspect of the lower jaw. And that's quite unusual. It's not really the case in you and I or most other mammals. It's a large nerve, but not nearly as relatively large as what you see in the platypus. And if we just continue to virtually dissect out that right jaw, going to the symphysis, and now moving into the left jaw, you can see even anteriorly it's this very large canal. And one of the reasons it's so large has to do with the electrosensitivity of the platypus bill. That's how the platypus can find its aquatic prey, so these little invertebrates, small animals that it eats, and it detects them not via vision or sound, but it can detect the very faint electric impulses of these prey items' muscular movements using its triangulation at moving its bill left and right as it swims. And that innervation, that sensitivity is conveyed back to the brain via this mandibular division of trigeminal.